In this unit, we're going to be looking at volume. So we want to first of all make sure that we understand what volume is. So there's a few ways that we can describe volume, and one way would be that space that an object takes up, 3D space. What I would like you to do is come up with your own words to kind of describe how you understand volume. So when we look at volume, it's important to understand that volume really is, in general, when we take some area, so basically I'm taking squares, and I'm going to give that area some thickness. So I times it by some thickness. And this is how we're going to start looking at volume and understanding volume. And this is just a new twist on the same thing. Most of us kind of think of volume as length times width times height, which is perfectly fine, but it's important to start kind of taking a little twist on it and looking at it from a slightly different perspective and thinking of it as area, and we're giving it thickness. When we talk about the shape we use to measure volume, we use cubes. When we talk about how much volume, we talk about how many cubes fit into the space. So we use cubes. Okay, that's very important that we recognize that we have to make cubes if we want to calculate volume. So when we're talking about volume, we're going from area, which is 2 dimensions, to volume, which is 3 dimensions. In fact, we can start from the very beginning. We can start with a dot, and we call that 0 dimension. And when we give it a line, extend it like that way, we get 1 dimension. If I want to go from 1 dimension to 2 dimensions, I give it some width. So I have length, and I give it width. And there's my area. So what we're doing from last unit to this unit is we're going to start with this square area, and we're going to extend this area 90 degrees in another direction to give it volume. Okay, so we take every corner of that area and we extend it in a direction of thickness, and that gives us volume. So when we think of volume, we think of it as area, and we're giving that area some thickness. So when we look at a rectangular prism, we want to generalize this rectangular prism. So there's no measurements on here. So when we talk about the area of the base of a rectangular prism, although I've drawn this as a square, really we can just say it's length times width. Okay, so I can just do length times width gives us that red area. Okay, that's the area of the base. And if we want to find the volume of this object, so here I have my square area, I want to find the volume of this block. What I can do is take this area and I can extend it by the thickness of this prism. So I'm going to call that thickness H. So thickness of the prism I'm going to call H. The volume of that prism is then going to be the area of the base. Okay, and now, although we expressed it here as length times width, I'm just going to say area, because we can generalize it as area. So we have area of base, okay, and the base is going to be that area there, and as long as every slice along the thickness is going to give us the same area, I can then just multiply it by its thickness, or times by h. Okay, so it's going to be area of base times the thickness, in this case h. So then the formula for volume, we're going to write it like this. The volume is equal to the area of base okay, so we're talking about that red area there. So that base, as long as a prism is when every slice is going to be the same area, and if that's the case, we can then find the volume by taking that area and multiplying it by the thickness, which we'll call h. And sometimes if we turn it the other way around, we can talk about that as height. So although it's perfectly fine to use volume as length times width times height, really it's important to understand that although this is perfectly fine to use, we should start conceptualizing this as some area, length times width, times some thickness.